The last presentation will be given by Agnieszka Rybak, who is the co-organizer of MOPS meetup and also senior MLOps engineer at NVIDIA and also CTO of Recognize.
Yeah, that's technically true.
Yeah, and she will tell us about Lego, latency, and life, and building MLOps on a budget. Yeah. So, let's start.
So the title is obviously LLM generated. It's not mine. But yes, we will talk about all of those things. And as Tomasz said, I work at NVIDIA, but I also have a side gig at Recognize, which is a site for recognizing Lego bricks. So, for example, if you have this Lego brick, do you know what that is? Like this one. Do you know what that is? No, it's anyone besides you. So, do you? So, what you can do with Recognize is you can take a photo of this Lego brick, and it will tell you that it's a tractor chassis from like 70s or 80s. So it's like really old. Like you probably like you can have that from like if you got that as a kid or your parents got that as a kid. But and you can tell that like, with this app. And how does it work? So when we get a photo of a Lego brick, you can see that it's a small one here. We do a detection on that to crop the image to have that one Lego brick. Then do encoding. So we have a nice vector of numbers, and we do a search. Just comparing this vector to other vectors and to see that it's the most similar to brick 2x2, and less similar to other similar bricks. Okay, but why? Well, this is a very good question. So it's just recognizing one brick at a time. So you may see like it doesn't really like why would I even do that? So you can buy a mix of Lego bricks, like 10 kilograms of Lego bricks, different ones. And you can resell them one by one on a site, for example, like Bricklink. And you can resell them for the whole 3 cents, which is still 3 times more than you buy it for in the mix. So you can actually make money by reselling the used Lego bricks. Okay, and so we know why, and now let's go through the challenges. Like, why is it even hard? So the first one is accuracy. Obviously, like the model has to work. Like there are over 85,000 of different Lego bricks that you can recognize, and it just have to be accurate. But we won't really talk about it today, because that's already covered. That's covered by Piotrek, that one, with all of the questions. And he does a lot of presentations of how to build the models to recognize the bricks better and better. So we won't talk about that. That's boring. So the next one is latency. So when we have, this is a picture from a Lego sorting machine. And Lego sorting machines need to do pictures of each of the bricks and categorize it accordingly so that everything is automated. So latency here means like it means like the higher accuracy, the less is the throughput of the machine. So we need that to be fast. We need that to be reliable, because this is our whole team, me and Piotrek, and we like to have sometimes vacation, for example. So we don't want to be on call all the time. We just want the site to work, just as is. And the third one is costs. So you've seen that it's 3 cents. So if the request to this website costs more than 3 cents, no one will use it. So it has to be cheap enough for people to use it. And cheap enough for us as well. So, with that, with all of that in mind, let's build a system architecture. So this is like a simple MLOps stuff that you probably may have seen before. We have some data that we use for training, that the trained model is deployed, and we have some inference, online inference that saves the data from the online usage, and we have to monitor that inference. So let's start with training. Training is the one of the expensive parts because it needs GPU. So like I work at NVIDIA, so I know that those are expensive. But what we can do to make it cheap? For example, we can use Kaggle. Kaggle has free notebooks that you can run for 12 hours at a time, and you get 30 hours a week and pretty old GPUs. So for the start, that's perfect. But if you want to run a training that is longer than 12 hours, then you really can't. So we had to move from Kaggle to something more, which was Colab Pro Plus. And that, at the first time it came to Poland, it gave you unlimited time, GPU time, with V100s. It was like $50 a month. V100s, so not the best GPUs, but good enough. And you could even run 2 or 3 trainings at the same time. And the max training was 24 hours. And that was pretty good deal for $50. And they kind of figure out that it's pretty good deal, so they changed that to tokens. And now it's not the credits. So you now get some credits and you're not unlimited anymore. So now it doesn't make sense. So that is fine-ish, but doesn't make sense that much. So we moved to some. So we first decided to listen to John Carmack, who said, "I am suboptimally frugal. I avoid developing big cloud jobs that would be valuable due to the not unreasonable expense. I should buy a big DGX station because then guilt over an underused expensive resource would make me work harder to fill it up." So we didn't buy a DGX station, but we bought one GPU, which is a 3090 RTX. And that is on our local machine. So that is on our local machine. And for now, it's cheaper. Well, it's not like it's that cheap. So you can see this is our usage, excessive usage. So I know it's in Polish, but it's for 2 months, and we pay over 1,000 zlotys for 2 months. Now, so it's not free, but it's still better than having a GPU on a cloud or somewhere. So this is our setup for the training. We have GeForce RTX, PyTorch Lightning, and an MLflow for experiment tracking. And this is just a local machine that's in our house. So we have now. So now we have a trained model. So okay, we have to deploy it somehow. Well, we have all the code on GitHub, so it makes sense to just use GitHub. GitHub is perfect. GitHub free. There are 2,000 minutes of GitHub actions. So we created a lot of GitHub workflows on GitHub actions. So we have image building, deploying deploying several things, deploying to different machines. Everything is automated. And one of them is build image. So if we're building an image, we have to keep it somewhere so that we can deploy it. Well, we have the GitHub container registry. So there are 3 quotas on that as well, but they're pretty small. Like it's like a 500 megs or a 1 gigabyte, and so we don't really know why, but we are not using any of that. Like we're keeping lots of images on GitHub, and they don't really charge us. So I don't really know why, but like probably let's not tell them. And we're still like everything is below in 3 quotas. Like we don't pay anything to GitHub. So this is our deployment stack. Now let's do inference. So for inference, well, we could have inference on a perfect GPU, like 8 GPU, H100 cluster, something, but well, no, that's too expensive. So we want a CPU for inference for the model. So we can buy a CPU, CPU machine from Google Cloud. For example, this 8 vCPUs, 16 gigs of RAM, $300 a month. Well, we can also do and have a VPS for $40 a month for almost exactly the same machine. And we don't really expect to have those spikes of workloads. So we don't really need to have cloud. We can just buy this machine and that it should be fine. So that's what we did. So this is just a VPS. And the stack for this for Recognize is we have Fast API as a backend, Vue.js as a frontend, Traffic as reverse proxy, and Docker Composer that binds everything together. So if it's a Docker Composer, it's nice. Like we can just deploy it anywhere. For example, first, we can deploy it anywhere. But first, a quick shout out to Docker rollout. So when you normally deploy something with Docker Compose, it just removes all the old containers and then creates the new ones. But if you use this, so it's a downtime for you. But it's if you use Docker rollout, you can do a zero downtime because it first creates the new containers and then kills the old ones, and the traffic is nicely moved from the old to the new ones. So it just works. If you have a reverse proxy, like you can just deploy your containers for your application, and it just works. So it's a great library. Not really a library. It's just a CLI tool. So if you have something like that, you can use the Docker rollout. And so when you have Docker Composer, you can just Docker Compose. You can just do 2 machines, for example, a dev and a prod. So that way you can test whatever you're doing. So this is the inference. So you've seen there is the backend, frontend, reverse proxy, but there was no data on that graph. But we have to keep the data somewhere. So for the sake of reliability of the whole system, we don't keep the data on the VPS. VPS can break. The disk can just stop working. We might need to move to a new VPS for some reason. There might be problems. We would have to migrate the data somewhere, and it's not that easy. So we just store the data externally on Google Cloud. So our VPSs just save the data on Google Cloud and reads the model and the index from Google Cloud. So we use the Google Cloud Storage and Firestore for the data. So no actual data is we don't really need the data that is on the VPSs. We just load it. We just load the model from Google Cloud anyway on the application startup. So this is the data module, and now let's go to monitoring. So for monitoring, we just use the simple Grafana plus Prometheus. That is a standard setup for most of the applications. And those are open source, so we can just put them, just deploy them ourselves. This is a nice Grafana dashboard that we have. We have our PSs, we have some errors, we have latencies, so everything. And we can just deploy it. And deploy it on the dev server, for example, because we want to not affect the production in any way. So we can just deploy it on the dev and just collect the data from both the dev and prod, and so that it's It just sits there. We have a separate deployment of that because it's not a part of the application. It's just the monitoring. And that is not all. Like this is just the beginning of the monitoring. So we also have Sentry. Sentry is also open source. We can also add it to the stack of the monitoring, but it also has a cloud. It also has a cloud account with free quota. Free quota is like 5,000 errors per month. So this is like an additional perk because like you have to resolve those errors because you might run out of free quota. So you have like additional, this is like an additional advantage. And there is also Checkly. So Checkly runs a scenario every some cadence of time that you choose. For example, you can just, we have two scenarios. One is pinging the API to make sure that the API works every 5 minutes. And the other is loading the whole website every half an hour. And that fills the free quota of that. And but we don't really need that because you can see that this is an email from Checkly that there's a failure at 8:43, and there is an email from a concerned user at 8:45. So it's still a bit better than the users, but not quite that much. So this is our additional monitoring that we can stack here, and this is almost the whole graph here. But we haven't talked about one of the things, which was latency. So for latency, we will dig a bit deeper into inference again. So this is our latency for the predict endpoints. So you can see that it's sometimes almost like for 99th percentile, it's sometimes like 1 second. So that's a lot. And it's over like the median is over 200 milliseconds. So we can do better than that. And what are we actually testing? So this is the baseline. So this is a fast API with Onyx runtime for detection and encoder, and NumPy for search. And for testing, we used the Locust, which is an open source load testing tool, pretty easy to use. Everything is in Python, and it just creates a swarm of users that start to use your application, and that's like fun. And it even creates like the nice reports in HTML, which we of course didn't use because if you're just running the load test several times, it doesn't make sense. But they're pretty nice. So this is a baseline. It's a bit different use, like the numbers will be different than you've seen on Grafana because it's a bit different. Like the number of users is different, everything is different. So it's the same kind of machine than that prod, but it's like the usage will be different, so the numbers will be different. So this is the baseline, over almost 500 milliseconds. So we thought, okay, let's try NVIDIA. Let's try. Like, they know what they're doing. They know inference. So we have some tools from NVIDIA that we could use. So of course it doesn't make sense to use TensorRT because it's just a GPU. It works. It helps with GPU. Like we have CPU workloads, so that doesn't make sense. So, but we can still try to use Triton Inference Server. Well, if you think about it, it doesn't really make it shouldn't really make your workload faster in any way, but because it adds an additional layer, so it shouldn't make your model really faster that much. But we can still try because it separates the model from the application. So maybe if it's the same, we can still use it because it's a nicer architecture. So we will just add that to the deployment stack. So we will have like everything and then Triton at the end. And this is the result. So we thought that it's going to be a bit worse, but not that much. And of course, it depends like with how you communicate with Triton. Like if it's JSON, it's like the worst. And with gRPC, it's a bit better, of course. But still, like on this small machine with like limited memory, like it doesn't make sense. Like it makes it much worse. So then we thought, okay, let's try optimizing the model. So here are some model changes that we did. Quantization and token merging. So they help a bit. So they help a bit. Like we started using that. Like the accuracy is not really sacrificed that much, so that makes sense. Then we thought, okay, deployment. Like we can do several. Like we did the whole grid search of all of the possible number of workers, number of threads, types of deployment, and Onyx runtime, just to figure out that the deployment parameters we were using were the best. So that didn't help at all. But we thought, okay, well, maybe the model is not the thing that we should actually be optimizing. So maybe we should optimize something a bit else, like something different. So this is a profiling of the application of the single request. And you can see that like there is the classification and detection somewhere there, but there is like a database. This is a search. This is like half the time is spent on search. So like, and how we do search. So we of course do search as Andrzej Karpathy says. So we just use an NumPy array because people keep reaching for much fancier things way too fast these days. So yes, that's what we did. But unfortunately, we have a lot of filtering that we do on that NumPy array, and it takes a lot of time. So we decided we will try some fancier stuff. And this fancier stuff was Kundrant, which is a vector database, which has nice filtering options that will just build the indices with the filters already, because we know which filters we want in Recognize. So we will just build that, and that will just look the same way as the Triton Inference Server. We can just add it to the deployment stack. We can. This is open source. We can just create a separate container, and we can just load the vectors on the application startup. So, and this is the result. So we have an exact search and an approximate search, which helped a lot. So we didn't even bother with the approximate search. We just used exact, which is almost as good, and it's exact. And after having all those things, we can see that this is now the search time. So this is much, much more like what we expected of the search time of this application. So now our inference just needs to be a bit updated because it needs now Kundrant as well. And we can see out Grafana that it helped a lot with the Kundrant, mostly Kundrant, helped a lot with our inference time. So this is a summary. This is the whole stack. You can see that we have training that saves the model and the index on the Google Cloud and reads the images from the Google Cloud that we deploy through GitHub to our VPSs that save every image you send to Google Cloud, saves the results and reads the models and the index. And we have monitoring with Sentry, Checkly, Prometheus, and Grafana. Everything is there. Everything works, and it's perfect. Thank you.
Thank you, Agnieszka. I'm not sure if you know that the meeting was recorded, so some GitHub guys.
I know, but like no one watches that.
So, do you have any questions?
I have two questions. First one, I'm not sure if it is specifically related to today's presentation, but I was wondering, because I assume that the learning is made like it is like a supervised learning. So I was wondering who actually associate the Lego parts with the proper Lego sets.
There you have our annotation specialist. Does that like 6 hours a day or something?
And the other question related to that is that in the example there was a simple like red brick, so there is one-to-many match. And how does the app handles that? So there are like I assume hundreds of sets that do contain that specific block.
Okay, so maybe I will answer the question. In here we are doing two different classifications. Either we will have a picture of a set and we will say, okay, this is this particular set, or a picture of a brick and we will say, okay, this is brick 2 by 2. And by the way, from our database, whatever, we will know it's in those particular sets, but this is actually not like the most important part. The important part is that we have to recognize that this picture contains brick 2 by 2, because then the sorting machine will know, okay, great, I will just put this to this bucket with the rest of bricks 2 by 2.
All right, thank you. And the last question would be, why don't you use the dark mode in Grafana?
I switched to light mode in Grafana just to make screenshots for the presentation. Yeah, it's a valid question, I know.
Thank you. The project is really cool. My question is very obvious. So, is your project profitable? What about the budget?
So, there is one problem with Recognize being profitable. There is no way to pay for it. So that's the main issue, and that is actually one of the top features that the users requested, to be able to pay for it, and that is in progress. We also have some clients that bought a model from us, like from Piotrek, obviously, because like I'm just deploying stuff, and they actually pay, and so that Recognize is like almost, let's say, ramen profitable. So those clients pay for the servers and for the domain and for GCP costs, which is if you just collect everything the user. That's true. That's true. If you just collect all of the pictures that the user sent you, and that's a lot, because that's like 100,000 per day right now, you have to pay a lot for storage eventually.
Okay, and the second question about parsing. So as I see, there are some sites where you can find actually already supervised data for your models. Have you tried to parse something?
For the models, or for
the database.
So we searched everything, and so we used all the data that is there in the internet that you could use, because because of the licensing problems. Most of them are not that good. Like for example, they are biased in some way. They're done like in the same lightning and everything. And there is also a lot of good data on the, for example, on Facebook groups, where people post a photo of a brick, and someone answers which Lego brick is that. And we even got banned on Facebook group because Piotrek started posting on that group with a link to Recognize. So, and they actually banned Recognize everywhere there, so you can't really post that anymore. But a lot of the data set now is pseudo labeling the data that we have from the production. But if you want to know more about Recognize, the like machine learning side of that, Piotrek has a great presentations already about that. It's like from EuroPython, from PyData, I don't know. Everywhere else? Yeah.
Deal.
Thanks for the very enjoyable presentation. Following up on one of the previous questions, I'm wondering what's the total cost of running this infrastructure? It can be a ballpark number, but maybe energy included.
That depends. Like how much do you eat, Piotrek? so exactly. The VPS is what, $40 a month, plus for dev is like 10. So for GCP, it's right now it's what, 150 per month. So overall, it's like 250, let's say, per month, dollars already, which is like, this is because we have a lot of traffic actually. And energy-wise, well, so the new a new model is actually like this. Those are training all the time. So I don't know how to count that like energy-wise. I don't spend too much time on Recognize. So this 500 zloty per month for the electricity. A bit less because we use like for normal life. I would say even 300, like $300, yeah.
So thanks for a very nice presentation. I have a question about vector search. Why Quadrant and what? Yeah. Why?
So we don't really have that many vectors. So it could be anything else like V8 or anything. We wanted it to be open source, so we could just host it like on the VPS, and we wanted filtering, and Quadrant is. It's not an American company, which is also like a good thing. Like we did that before Trump, so it's not Trump related, but still it's always nice to fund something that is not American, like not fund, but use something that is not really not American, as everything is nowadays. So we don't really have like a strong opinion on that. Quadrant works well. It was easy to set up, so we didn't really have any problems with it. But we probably could have used anything else.
Okay, so and how about filtering? Does it like affect performance quite a lot or not? Or?
With Quadrant? No, because it filters, it like pre-filters that. It has a nice searching capabilities of like it if you know the filtering that you want to do beforehand, it can just build the vector search, like build the index based on that, and we just filter on, like we don't have. So the filtering is a problem when you have like high cardinality of the field that you're filtering on, but we don't. We just have like 4 values of that, so it's not really a big deal.
Okay, got it. Thanks a lot.
Thanks.
Okay, so thank you very much for the presentation. My question is, what is like the time frame of the project from training to the end?
How much time does it work for just one model?
Yeah.
So I think that the most time is just the training. So the baseline, like the base model, the pre-training takes 36 hours, something like that. And then there is a fine-tuning that takes like 8 hours, right? 16? Oh, it's like now it's 16 even. So that is the most time. And then deploying that model like to production, that's just like 1 line in the code, 2 lines, because you're changing probably the code and the index. But that's just 2 lines, and the deployment takes like 3 minutes. So the deployment is pretty fast, but the training time, and if you want to first do pseudo labels on all of the data that we have, that takes several days currently.
Okay, thank you very much.
Any more questions? Oh,
Thank you very much. I just want to ask about a slightly different use case where you have to be quite frugal. University teaching. Because we've been running a post-diploma course, a pilot, and in term one it was quite straightforward. We're teaching the basics, they can use their laptops. Term two, we do things like MLOps and generative AI, etc. And then they're going to need to use a lot more CPU and GPU to do interesting things. And okay, we can sign on the cloud services and try to use, you know, a certain amount of free stuff. But the students are actually terrified at that point because they have to get their credit cards out in case they do something stupid like leave the thing on an infinite loop for a week. I forget to shut something down.
Yeah, yeah.
Are there any learnings from what you've done here that perhaps could be maybe adopted by maybe university teaching in order to give a cost-effective way of allowing students to actually play with some decent compute power beyond their own laptops?
So with cloud computing, it's always a problem if you just leave something running. But there are alerting systems for the cost. Of course, they don't work that well if you just spin up a whole bunch of GPU heavy instances. It will alert you a bit too late. Like you will have to pay for it anyway. So, oh yeah, that's another thing. Well, there are. For example, I don't think like Kaggle needs you to give them like the card number. Like if you buy something that has credits and you just buy credits beforehand, then it's just that you have a cap. Like you can't really use more than that. So like with Collab and like with Kaggle, you can just use the free quota, and you shouldn't be able to just go over it. So that's like definitely from the psychological perspective. That's yeah. I would say that prepaying is definitely less scary. I wonder if you have anything more. Do you have anything more?
Yeah, maybe one comment. We were definitely scary. That's why we are not using Google Cloud or any quite that much. We only use it for storage, but we are like, you cannot actually pay a lot of money for storage. Like obviously if someone DDoSes you and sends you a lot of pictures, a lot of requests, okay, you will, send a lot of pictures, store a lot of pictures, but we have some rate limiting and so on, so you cannot actually do this. And you cannot make any mistake in a code because the code is running on VPS, and we are paying, every month $50 for compute. And this is also one of the reasons why we decided to use the compute that is fixed cost, because otherwise it is scary. Like there is no way to prevent it. Obviously there is alerting, but it will tell you, okay, you exceeded your budget, you have to pay $10,000.
Yeah, and there is also like one thing that I always say with using cloud: always check the egress. that's not really connected to our work, but like always check the egress. Like we had problems with egress as well, and with Firestore. That like it's not really that easy to calculate how much you will pay for a service. So there are calculators, but still, like you're probably like the first time you're probably gonna have some mistakes, like and pay much more than you thought.
Yeah. So interesting statistics. Every picture that got to Google storage, we actually download it also to our local storage because we don't trust Google. Maybe it will fail. We have a backup locally, and also when we train the models, we want to train locally, so we have to copy those. And this is like 1/3 of the costs to download the images. So it's crazy. And also a big part of storage is actually not the storage of images, but the action of uploading the image, because for each action you do on Google Storage or S3 or whatever, you have to pay a fixed amount of money for some action, like uploading the image and then for storing the image. And actually just uploading those images costs more than storing those images. And the cost from moving the image from like the hot storage to cold storage also costs a lot, actually.
Yeah, because it costs as an action on the cold storage, so it's actually more expensive, and like you have to like think if that's worth it. Like in the long term, it is because the storage is cheaper. But if you have like lots and lots of files, then those actions are pretty expensive. And you remember we even used for some time Google Drive instead of Google Storage because egress on Google Drive is free. The storage is a bit worse, but the egress is free. If you buy the yeah, so yes, so just to repeat what you say, 8 zloty for a month for 100 gigabytes of storage.
Okay. Are there any questions? So we don't have any more questions. So thank you, Agnieszka, for your great presentation.